Hi, my name is Dan Giza, and in this video I'll be demonstrating the operation of my final project for the EE500 Embedded Systems course. This project was developed on the Land Tiger Development Board, which features an LPC 1768 ARM Cortex-M3 microcontroller. For this project I just chose to develop 2 pages of what would be part of an interactive children's book. My main goal is to provide a mechanism for young readers to interact with pages of a book using some simple passive tools and sensors contained within a given page. The sensors chosen for this application include several Hall effect devices, or HEDs, and capacitive touch electrodes, which are easily hidden beneath the artwork of the page and not visible to the reader. Capacitive touch is implemented using an MPR121 integrated circuit which communicates with the LPC 1768 via I2C protocol, and the HEDs are used in conjunction with several small magnets arranged within some 3D printed parts. 2 photocells are also used, 1 per page, and they're used as in a simple voltage divider arrangement and read through the analog to digital converter in order to determine which page is currently active and what part of the code to execute. The general concept for the book is that it's taking place at a zoo, and each of the pages depicts an animal that is in need of some assistance from or help from the reader. The artwork on each page, as well as some LEDs embedded within the page, provide contextual clues as to how to solve the puzzle, and a green LED is illuminated once the page has been solved. Once the page has been turned, i.e. the photocell is no longer exposed to light, the variables related to the solution of that puzzle are reset so that the reader may return to that page and solve the puzzle again. Next in this video I'll show the operation of each of the 2 pages and provide a more detailed description of its operation. So this is the first page of the interactive children's book, and the LPC 1768 knows which page it's on first due to the photocell in the upper left-hand corner. And so over on the LCD screen, it shows the page 1 and page 2. Each of them have a photocell, and each one of them is being read through one of the A to D converters. And so you can see page 1 is a significantly lower hexadecimal value, indicating that's the active page. Page number 2 is dark right now, and you can see that's a much higher value, and so that's how the microcontroller knows which part of the code to execute. Over here, which we'll also talk about these back on the other page in a minute, but this is the status of each of the leaks on that page. HDs 1 and 2 are used to control the commutation of a water supply handle, and then the handle count is how many commutation cycles it's identified, and then the bottom line here indicates that the page is not yet solved. So back over on the page, this is a seal or C-line enclosure, and the problem that the reader has to solve is that there's 3 cracks that are in the enclosure that have to be plugged, and then you also have to turn on a water supply to refill the tank. So you can see these are controlled, the leaks. You can plug a leak by just simply touching the page at the point of the leak, and then you let go, you can see that the water starts to flow again. These are actually just electrodes that are controlled by a capacitive touch sensor, an MPR121, that communicates to the development board to the LPC 1768 via I2C protocol. And the HED 1 and 2 that we saw over there on the LCD screen are embedded within the page, and they are spaced 90 degrees apart. And then the rotor that we're about to spin has magnets that are spaced 6 degrees apart, 6D degrees apart. So the magnets and the HEDs are spaced such that the 2 HEDs can actually identify the direction in which you're spinning. So the user would have to identify which tool to be used to solve this page. In this case, they would want to choose the handle and insert it into the component within the page. And then as you begin to turn the handle to the left, you can see that the water supply begins to drip. And just with a small amount of rotation, it drips relatively slowly. And we need to turn the supply on fairly full in order to be able to refill the tank. So we'll just rotate a little bit more. And so now it's on at quite a bit higher flow rate. And so now what should happen is if we plug the leaks and we have sufficient water supply, then the page should be solved. and that would be indicated by this green LED over here on the breadboard. So if we plug all 3 leaks simultaneously, the page has been solved, and now that the page has been solved, you can let go. None of it resets. If you do turn to the next page and then you ever come back to this page, when it goes dark, you can go see over there on the LCD, the photocell is now showing a much higher hexadecimal value, indicating that it is not exposed to light. And then when you re-expose it to light, the page is reset and you're able to solve it again. So this is the artwork removed from the seal page, just to give a better idea of how it's working underneath the hood. Each of these sets of 3 LEDs is 1 leak. This 4th set of 3 LEDs is the water supply, and you can see the electrodes that are on the back side of the artwork. And those are what control or what are detected by the MPR 121 and communicate back to the board whether one of these is touched or not. And again, this is a capacitive sensor detected through the paper of the page. And then lastly, these are the 2 HDs that control the commutation of the water supply. And so again, they're spaced approximately 90 degrees apart. And then this is the rotor that goes along with them. This was 3D printed along with the hub that it rests on. And so the magnets are spaced 60 degrees apart, and they alternate north and south pole. And so there's a change of one of the HHD states every 15 degrees, and you can tell the direction in which you're turning based on which HUD is leading and which one is following. So for example, if this HUD changes state first, and then after you detect that this HUD changed to that state, you know that you're spinning in the left direction and vice versa. So this is the next page. In this one, the problem that the reader has to solve is that there's a fire in the tiger's enclosure, and so we're going to draw upon what they would have learned in the previous page, which is using the handle to turn on a water supply. But then we need to have a way to get the water supply over to the fire to help to put it out. So quickly looking over at the LED or LCD real quick, you can see page number 1 is now the dark page, and page number 2 is the one that's slightly brighter. I've turned off the lights here so it's a little easier to see the LEDs embedded within the page. And on this page we have an amount of water that we've poured on the fire, H2O to fire, and that's currently at 0. The bucket location is identifies whether the bucket is underneath the water spout or if it's over the fire, and that's controlled with similarly as the water supply rotor with 2 HEDs. And then the bucket level is currently how much water is in the bucket. HED 1 and 2 are the same HEDs effectively as the previous page that control commutation of the water supply, and then the handle count is how many times the handle has been turned. And this, again, the last line shows that the page has not been solved, so I'll just expose it to darkness to reset everything there, and back over on the page. So again, the user would use the same tool. So when they're done with the previous page, they would take this tool out and put it back into the side of the book or somewhere to be used in later pages. So in a similar way, you would install the handle, and if you turn it to the left, you'll begin to make the water supply on this page strip. And then, again, we need some way to get the water over to the fire. So in this case, we have a bucket, and on the reverse side of the bucket is just a simple magnet that's going to trigger the HED that's either below the water supply or on top of the fire. So if we hold it over here, you can see on the breadboard I have a couple of LEDs that indicate the bucket level. So for each drip, we catch that drop in the bucket, and then it takes 3 drips to put out one part of the fire, one part of the flame. So now if I take the bucket and put it on top of the fire, you'll see part of the fire go out. Now I can come back over here, and you can catch up to even only 1 drip at a time. And you see there's only 1 LED lit. That means I only held the bucket there for 1 drip. And if I take it over the fire, it does add that drop of water to the fire, but it's not enough to put the next flame out. So what you have to do is hold it there long enough to collect enough water, and then come back over here, and then put it on the fire. And then one more, we'll collect one last bucket full. And once you pour that last bucket on top of the fire is out, and the green LED indicates the page has been solved. And back on the LCD you can see that we dropped 7. That was before the last fire LED was turned off. In reality we would have had to have been greater than 9. It just doesn't update the screen after the last flame is put out. It just says that the page has been solved.